I will tell today about things that many of us hear every day, but few of us use in our regular work. So please, next slide. Yeah, I'm working in Exactly, and we are focused on creating customized generative images for different artists. So they upload their images, and we create the models in their style, and they have full ownership of it, so they can sell it and use it in commercial purposes. Please, next slide. Here are some examples. So we need to create very diverse models instead of using some general ones like basic stable diffusion. So we need a lot of fine-tuning models and creating new features. So next slide. So that's why we're so motivated in high performance for PyTorch. And the new second version of PyTorch really brings us new cool features that in total speed up our fine-tuning procedure, I think up to twice in terms of speed. Please, next. Yeah, first of the things is Torch Compile. It's a new pipeline for compiling your model. Previously it was Torch Script or Torch Trace, but now it's Compile, and it has really cool API, and they boost the performance in both training and inference regimes. And the model that you compiled with this new method can be used in many frameworks. For example, you can easily load it in C++ code, or you can use it inside, for example, OpenVINO for deploying models. So you just save it and load it. Here, example. So everything you need is only one line that compile your model. And next slide. It has really great performance, and the things that is really cool is that now it has dynamic shaping. So you can pass as input the tensor of any shape, and it works really good with custom layers. So I really recommend it. But yeah, it has three options for basic large models, for small models, and if you want to have the fastest model and it's not critical for you to spend some time for compiling model. Here's some toy example with classifiers. So yes, on the first, we're just training a classifier, and on the first iterations, it needs some time to compile, but in next iteration, we can see really good performance, and it's really helpful to decrease training time. Yeah, next thing is distributed training, because sometimes we need to train models with larger batch size, for example, in NLP tasks or in some Bayesian tasks, for example, tuning stable diffusion model or any other diffusion. So yes, they really improved the option for data parallelism when you create copies of your model and you train it with different data on different GPUs. But there's also one more new thing. It's sharded training. So if you have models that you can feed in your 80 gigabyte GPU, you can split it. So now you can split not only data, but the model. So if you have really large models, you split parameters across different GPUs, and you can train with this new option. Next slide. And again, it's really simple API. So for data distributed parallel, it's only this line. And for fully sharded training, it's this line. For now, you can't use both of these things simultaneously, but still you can create some custom implementation and make it if you really need it. So yeah, that's how it works. So yeah, use sharded training for training really large models, and data parallel for training with large batch size. Next slide. And also, in the second version of PyTorch, they really improve attention mechanism because nowadays it's not only applied in natural language processing, but also in computer vision, because the best models are obtained from visual transformers. And there was developed new memory-efficient method called XFormers, but it was a third-party implementation, and it was not natively implemented in PyTorch 1, but in the second PyTorch, they implemented it inside with custom kernels, and it really has a great improvement comparing to this third-party implementation, so it's up to 50%, and it's really better than previous implementation, native implementation in PyTorch, because now you can use large batch size and train your models or inference them. So here are examples for full precision, and next slide is example for half precision, where still we have some advantages. And yes, also they implement not only memory efficient version, but also flash attention. It's also a different implementation without any approximation, and it works only with half precision floats, but it's slightly faster than memory efficient regime. But it requires some construction for your attention layers, because now you head dimensions should be divided by 8 and 4 depending on your precision, but still it's really good because all state-of-the-art models already has this restriction. And yeah, here are some numbers. This is the function that they implemented. It's really already used in all APIs. So in numbers, it saves memory from 20 to 100%. During training, it saves time up to 70%, and during inference up to 20%. And also, if you don't have already an architecture and you create your model from scratch, you should think about creating it with small head dimensions, because when they are small, you really can obtain a good performance both in speed, up to 3 times, and in memory, up to 40 times. Next slide. Yeah, also it's mixed precision. I really recommend it because it's very easy thing. It's just use for some parameters of the model it use full precision, for some of the parameters it use half precision, and it's work in automatic way. Next slide. So you only need to create a context manager, and that's all. But if you work with float 16 half precision, you should be aware, because of the numerical range that is decreased. It may happen that your gradients are vanished or exposed, so it's better to use gradient scaler. And next slide, but I really recommend to use new brain float developed by Google, because it has the same number of bits for exponent, and that's why it has the same numerical range. And using brain float, you really don't need to use scalar. So you just change the precision of your weights and train your model. Nothing special. Yes, I think I said it. Yes, we recommend it to use because float 16 sometimes very unstable in terms of training. Next slide. Yeah, the one great thing that also I want to mention is gradient checkpointing by OpenAI. Please activate it. So yes, in the classic way, when we train our model, we make a forward pass, we store all the computational graph and use it to find the gradients. Next slide, and activate it. So yes, in gradient checkpointing, you can checkpoint some intermediate step, and then you don't need to store all your computational graph. You need to make an additional forward. It's partial forward. So yes, the gradient checkpointing is a trade-off between memory and time. And if you really need to save your memory and you don't need to hurry, so I really recommend to use gradient checkpointing because it's very useful. And next slide, this is how to implement it. There are two ways. You can easily just choose in what part of your network you want to checkpoint activation. On next slide, if you have sequential model, you can just create sequential checkpointing and checkpoint every second or every third activation. And in our experiments with diffusion models, it's really beneficial because it helps us to save memory and increase batch size of the training. And also it's great because it can be combined with mixed precision. Next slide. So yes, that's all about great things in native PyTorch that I really recommend and that can increase your training twice. Next is just some frameworks that I also recommend that are based on PyTorch and really useful for computer vision. First of all is Cornea. Cornea is like an OpenCV for computer vision, but it's natively on PyTorch. So it works really fast if you implement and deploy neural networks. It's really easy to use, and it's always creates some new computer visual features. Here are some examples, some basic examples like filters, color transforms, some warping, 3D point cloud processing. And the main thing about Cornea, it's differentiable. So if you want to use these transforms during your training, you can backprop it because it's natively on PyTorch and it has all backward functions to make a backward pass. Next slide. Yeah, and if you also needs to it's again about training, not about deploying. The great thing is accelerate by Hugging Face. Next slide. It combines all the cool features about training. So it combines mixed precision, gradient checkpointing, gradient accumulation, and it automatically detects what environment do you have and how it should be distributed over this environment. So instead of writing these lines that I previously presented, you can make the following thing. Next slide. You can easily initialize the accelerator and use it in your training. So it's very easy API, but it works really great in terms of set of features. So I really think that it's a great implementation. Yeah, one more thing, it's just funny because recently PyTorch implemented meta device. It's when you can create tenders without any information in it. So it's just empty tenders with some shape. And now you can initialize models that has no weight. And it's really useful when you have large models and you don't need to twice the memory while you're creating it. Next slide. And also cool thing is CPU offloading. Please activate. It's when you don't store all weights on GPU, but just pass the activations and change the device for next parameters that should be used. It's also implemented in main libraries like diffusers and transformers. And it helps us to work with really large models like Llama or large diffusion models. Next slide. Yeah, and the last thing I want to mention is IE template by Meta. This thing is about deploying. Next slide. So yes, it's a framework to not to compile, but to create a template on C++ GPU for your models. And if we tested it for Stable Diffusion, and it works really great because we have up to 3 times speed increasement. And next slide, it really works good with larger batch size. So it's really easy. And please use it because it costs you nothing, but it speeds your networks really well. Thank you. Maybe some questions.